Stepanenko, and this is my submission for Lab 4 of Embedded Electronics, where I built a digital to analog converter. The purpose of a digital to analog converter is to be able to add combinations of digital discrete signals to create a smooth analog continuous curve. A way to do this is presented on the Cook's diagram, where we build a resistor R2R ladder. The switch with the red arrow pointing to it would add twice as little voltage as the switch with the blue arrow pointing to it. This trend continues along the 3 bits. This means we create a system with 3 information bits that allows us to output 8 different voltage levels. Using the timing shown on the diagram right now, where the first switch has a period of 2 seconds, the second switch has a period of 4 seconds, and the fourth switch has a period of 8 seconds, we can observe the 8 possible states that we're in. It should be noted that the probe voltage is inverted. We observe that there are 8 different voltage levels that are outputted, which allows us to approximate several different functions. For instance, we can use it to approximate a sine wave, which is what I did in this lab. Using a correct combination of digital inputs, of discrete inputs, we can create a triangular-ish wave that follows the sine curve. I am presenting this with a drawing. The issue is a sine wave is centered around 0 volts, while the output that we get from the original digital to analog converter is not centered at 0 volts. It ranges from 0 to minus 4.2 volts roughly. This means we need another component to be able to shift the net voltage upwards by around 2.5 volts. Which is done in the following way. I added a voltage adder component, which, as we can see, our V out is equal to negative V sine plus 2.5 volts. That plus 2.5 volts shifts our possible outputs from 0 to a peak of 2.5. This means we now have a possible range of 2.5 to minus 2.5 volts, which, if used correctly, would allow us to create a wave. This is the physical circuit on the breadboard. The 3 orange wires are the 3 logic inputs that we use. I coded them to follow a particular sequence that allows me to mimic a sine wave. This is the op-amp part of the circuit, which has both the voltage adder and the digital to analog converter bit. As we can see on the picoscope, initially, before the voltage adder, we have a circuit that somewhat mimics a sine wave. It looks very blocky due to the fact that we only use 3 information bits, which isn't enough to properly approximate a wave, but we can see it does have a certain period. Now, after running it through the voltage adder, it becomes this red wave, which, as we can see, is centered at around 0 and has an amplitude of roughly 2.5 volts downwards and 2 volts upwards. The reason it's not symmetrical is because, again, we only have 3 bits of information to use, which means it's not enough to create a perfectly symmetric wave. Thank you for watching.